Okay, class, let's continue our solutions for test number 2. So we have here the questions asked us to evaluate the following functions, right? At the values 5, -1, and x minus 2. And our function is f of x equals x squared plus 1. So for our solution, all they're typically asking us is what will be f of x if these values are 5, -1, and x minus 2. So f of 5, meaning that wherever I see x, I'm going to put 5. It'll be 5 squared plus 1. That gives us 25 plus 1 equals 26. F of -1 equals -1 squared. In this case, it's a squared here. Plus 1 equals 1 plus 1 equals 2. Then f of x minus 2, again, wherever I see x in my function, I'm going to put x minus 2. It's going to be x minus 2 squared plus 1. And when I do the math, I could just spread this out even more. Say x minus 2 times x minus 2 plus 1. So we can use FOIL, as we've been doing. That's 1. That's 2. And this is 3. And this is 4. Okay. So when we do that, what do we get? You're going to get x minus x times x is x squared, right? X times -2 is -2x. Negative, this number for number 3 here, -2 times x is -2x. And then -2 times -2 is a positive 4. Put all that in parentheses, plus this 1 right here, okay? When we go further, we can now say that x squared minus 4x, because I'm adding these two up, plus 4 plus 1, okay? So now I could say that my f of x minus 2 equals x squared minus 4x, and then this 4 plus 1 happens to be 5. Okay, so these are my answers. Okay, these are my answers. This is my answer right here. Okay, so I have another problem here. The actions to classify the given function, and that function happens to be f of x equals 9x minus 6 over 9x plus 6. So that's the function. We got to determine if the function is a polynomial function or a rational function or a root function. And they want us to find the domain of that particular function and write that domain in an interval notation. Okay. So for our solution, okay, we know just looking at this expression here, it's a rational expression. So therefore, for number 1, it's going to be a rational function. Right? So going back to chapter 1 of our course, we talked about what is a rational number, what is an integer, what is a whole number. So typically a rational number is nothing more than a quotient. Okay. So number 2, they want us to find the domain. So in other words, how you do this is the domain again is the input. So you just want to ask yourself, on what number, when you look at the number line, this is my 0, this is positive that way, this is negative that way. What number will not make this function legitimate? Okay, or what number, if I plug into x, will not make this function possible. So just kind of look at the denominator. In any case, you don't want your denominator to be 0. You don't want that to be, because if I have a number, let's say 1 or 2 or 3, expression like this typically is undefined. Okay, so we don't want that. So look at the denominator. Your denominator here equals 9x plus 6. So you want to ask yourself, what would make this go to 0? What would make 9x plus 6 go to 0? Okay, what would make that go to 0? Well, if I actually if I take x to be 9 negative 2 over 3 plus 6, I know that 3 goes into 9 3 times. 3 times negative 2 is negative 6 plus 6. That goes to 0. So you know that at negative 2/3, you would not have, or your function is not inclusive of that number. Okay? Or you could do it this way, as I showed you earlier. You set your denominator equal to 0, right? Equal to 0. And you solve for x. That's 9x equals negative 6. X equals negative 6 over 9. When you reduce it, you're going to get negative 2/3. So you know that x 2/3 is going to make this denominator go to 0. Okay, by that being the case, you know that you're going to have 2/3 here. Okay, so, and this is going to be open on your interval. So for your solution, or your domain, is going to look something like this. All the values going from the left of negative 2/3 are valid. All the values going from the right of negative 2/3 will be valid, but not at 2/3, right? Because 2/3 makes, if I plug that back into x here, it makes that denominator go to 0, and we don't want that. So you can typically write your domain as this: negative 2/3 in union with 2/3. Okay, so that's for number 2. Then number 3, third part, you want to look at, they want you to, okay, so I actually solved the third part. So they want you to write they want you to write it in the, once you find the domain, want you to write it into interval notation, which we did right here. This is the interval notation right here. Okay, so that solves that particular problem there. Okay, let's look at number 16 very quickly. To actually use the graph to determine the domain and the range of the function. Okay, so in this case, you're looking at, again, your domain is your input, and that's along the x-axis. Your range is your output, and that's along the y-axis. Okay, so you want to look at, for the domain, you want to look across and say, okay, well, this is my x value here from this graph reading from left to right, and then on the x-axis, I have a 2 going towards the right, and then a negative 11 as far as this particular graph is concerned. So your domain, which is along the x-axis, equals, since this is an open circle, it's going to look something like this: negative 11, comma 2. And I'm looking at this 2 right here. That's the x value. Again, we're going along the x-axis. For the range, okay, I'm looking at the y-axis. I'm looking how high is this graph, okay? So with that being said, again, it's an open circle here, so that's going to be um, open parentheses, negative 11, comma, and it goes a high of 5. A 5 right here. Again, the range along the y-axis, and that's 5. Okay, so that's typically your answer right there. Thank you very much. I'm going to continue with the rest. But if you have any questions, just kind of let me know, please. Thank you. Bye-bye.